Hello everyone, I'm Kordell Snyder and I decided to do mechanical engineering this year. Alright, so can anyone tell me what these are?
Engines.
Good job, y'all are smart. Okay, so this engine is from the new 2015 F-150 V8 diesel engine. Okay, this is a C27 Assert engine. None of y'all know what any of that means, don't worry about it. Okay, so this engine is going to be used in basically any kind of industrial equipment. So you know the big dump trucks you'll see on like mining site, like jumbo ones, the tires are like twice the size of me. That's going to be powering those. Okay, so the dimensions on this, for a comparison, in the Ford engine, the length of it is going to be 30 inches, the height is 27, and the width is 32, or the width is 32. The length of the C27 is going to be 74 inches. Height of 63 and a width of 54. And then a weight comparison, this engine will weigh by that self, just without the transmission and all that, the basic engine will weigh about anywhere from about 600 to 650 pounds. Okay, this is the C27 Assert engine will weigh a little over 3.5 tons. Okay, so I know you can't tell much from the picture, but if I was standing next to that, my head would go up to about that black thing right there, and that's the top of my head. So very large. The horsepower comparison is this horsepower engine, which is a diesel engine again for an F-150, will provide anywhere from about 300 to 400 horsepower depending on what RPMs you're running at. This will produce a minimum of 1200. So very powerful. Just quick introduction so you guys understand what the comparison is between a industrial engine and a commercial automotive engine. So a little bit about me. I'm the oldest of two. This is my little sister Sloan. She is a 6th grader at Pioneer. She'll be going to Pearson next year because they're opening a new one. My dad is a CEO of a company called Grable Moving. It's a commercial moving industry with for cross-country moves from state to state, top to bottom, you know, that whole thing. My mom is a fashion merchandiser, mentor of Elisa. She works for 7 for All Mankind. She's been there for a little over 6-7 years now. She loves her job. That's just a little thing. I'm in the National Honor Society. This has been my first year. I'll be in it again next year. Play football. This will be my 8th year playing. I love the great outdoors. I love being out there. Live there for the rest of my life and be perfectly happy. So the reason I chose mechanical engineering is a strong influence from my uncle. My uncle is what I guess some of you would call a handyman. My entire life I've grown up having him influence me with how to work with my hands and repair stuff. You know, fix this. Okay, that pipe's busted. We got to change that. Or you know, basically, okay, we need to change the oil in the car. We need to change a tire, change a brake pad, anything. So he's really influenced me on how to, you know, use my hands and got me interested in that kind of concept. Another reason I chose mechanical engineering is because there's so much creative options you can do with it. You can go anywhere in the world. You can do anything you want. And as I'll say later, one of my mentors said one thing that really stood out to me is the most exciting thing about being a mechanical engineer is being able to create something from nothing. And that's really one of the only professions you can say that about. So as again I said, you can go anywhere in the world. There's always a need for them, whether it's in the oil and gas industry, electrical production, which would be a power generation, engines, generators, anything like that, or even basically like working at your local chip factory building a bag, designing the bag. So this is a quick little video about what life would be without engineers. So. And it kind of hypes it up just for a joke. It's more of a humorous thing than.
clients need a customizable testing system? Turn to the leader in measurement and automation technology, our solutions to test your products.
So basically that just goes over a few things about how different life would be and how many modern accessories we have nowadays that you would be without if you were to not have an engineer to be able to test and produce the things that we have now. So for my main research, I focused a lot on modern developments in the field of more power generation, more generators, more electrical power supplies, whether it be from a generator, an engine generator, or a diesel engine, or a nuclear engine, and that kind of thing, as well as the career outlook as far as job expectancy, what kind of jobs will be open, where they'll be hiring, and the different locations that you'll be able to work. So I had 5 interviews, and my first interview was with Mr. Jeffrey Johnston. He is the CEO of a company called Zodiac Aerospace. They manufacture airplane seats for commercial airliners, and they're responsible for making sure that in the event of a plane crash, the seats do their best job to keep you alive and keep the safety factor involved. My second interview was with Dr. Randall Burrell, who works for Raytheon in their supplier distribution section of the Raytheon company. Raytheon is a defense contractor for the government, and he said that his job was specializing in manufacturing and distributing radars that'll go on fighter planes, naval ships, and that kind of thing in order to detect objects moving near and far. My second interview was, or my third interview, sorry, was with a Mr. Zach Story, who was a great guy. He was tall, really tall, a lot taller than me actually. He graduated from UT, and he majored in mechanical engineering, and he worked for Holton Caterpillar, and his job was a project manager, which a project manager's job is to facilitate the production of a project from start to finish, whether it be the beginning of receiving an engine, packaging it separately with an accessory, or getting an engine, completely overhauling it, making it how the customer wants it, and then repackaging it how the customer wants it, and then distributing it. My fourth interview was also with Mr. Story. We had a dual interview. Was with Miss Kate Short. She is now my mentor. She focused a lot on being able to understand the differences in the types of engineering. There's electrical engineering, petroleum engineering, civil engineering. There's so many different types of engineering. And she was really stressing to me that to make sure that I wanted to go into mechanical engineering, because she really said that mechanical engineering was such a broad field that there was no doubt in her mind that you could go anywhere in the world and work for any company and do any type of engineering job with a mechanical engineering degree. Because in order to get a mechanical engineering degree, you have to basically you have to go through enough classes to get a minor in electrical, petroleum, supplies, manufacturing engineering, and all that different type of engineering. And she really wanted me to make sure that I knew that that's what I wanted to do, so I could apply that learning and get a better education. My fifth and final interview was with another friend of Mr. O'Burrell's at Raytheon. His name is Randy White, Mr. Randy White. He really stressed to me the importance of being able to understand how the different sections of engineering work and mix together, as far as whether a oil and petroleum engineering company over in the Middle East is working with, like Mr. Jeffrey Johnston's company, Zodiac Aerospace, in order to design a plane or something, or a fuel tank, or just the being able to understand how the companies mix together in order to create like products and like similarities, and to make an overall greater product than what there was before. So my mentor is Ms. Short. She works for Holton Caterpillar. She is a project manager. She has a Bachelor of Science in Mechanical Engineering, and she's been with Holton Caterpillar for 3 years and 5 months. And she says that it's really her favorite job that she's had ever since she's been out of college. She said that since she's been out of college, she's had she said she's had 4 engineering jobs, and that this was definitely her favorite because it gave her the freedom to be able to do what she wanted with engineering. She said that as a project manager, you got to actually experience the customer buyer or the customer seller relationship, and being able to understand that, and being able to understand what the customer wanted as compared to hearing it from a distributor or a salesman and having them relay the information back to you. She said it was a really great experience being able to understand the exchanges that go on and being able to understand what the customer wants, and that overall led to a more efficient way of creating a project and making it so the customer was more enjoyable with it. So in my mentorship, I've had a lot of hands-on experiences. Every time I go down there, she takes me out into the yard where they keep all their newly ordered engines in for their new projects, or she walks me through and introduces me to all the guys who work in the shop. They have me turning wrenches, cleaning stuff out, putting stuff together, all that good jazz. I've had, like I said, she's introduced me to multiple people in the company, whether it be the shop. She's introduced me to the floor shop manager, a lot of the people who actually work on the projects themselves rather than just facilitating them. And I actually have been able to sit on a few presentations from distributors who will be selling to her in order to make for accessories to put on their products. So I was able to sit in on a presentation from a company called Ace Coolers, and they specialized in a new type of radiator that they had just come out with, and they were trying to give a pitch about it to them. And that was really cool for me, being able to sit in on that experience and being able to understand both sides. And I was able, instead of listening for, trying to understand if I was going to buy it or not, I was able to just listen to it as an overall thing. And I was able to understand the different points of the sellers who were coming in and giving the presentation. I could understand how they were trying to stress that, their product's good, their product's better, their overall, they're trying to convince us as compared to being able to be to understand what Ms. Shorp and all the other engineers that were sitting in on the presentation listening to the sales pitch, wondering if this was going to be a good product for them and their customers for the future, and being able to overall just understand how much better it could be. But with where I was sitting, I was able to understand both perspectives, and I was able to take a objective point of view and being able to understand the different presentations. Before I go to the next slide, if you look at this engine in the background, that is a C27. So as you can see, it's very big as a size comparison. That one was going on a fracking trailer. For what a fracking trailer is, it's a trailer, obviously. Put an engine on it. They put a drill. They'll take it out into where they believe there be oil or natural gas, and they'll start digging. And fracking, basically, fracking is the way that they test for oil. They drill down, they drill a hole, and then they pump sand down into it, trying to push oil back up to see if there is actually anything worth setting up an oil rig, drilling, pumping oil out for. So for my original work, I did a lot of research over the different types of power generation when it comes to diesel engine generators. I didn't originally start off with this as what I wanted to do my original work on, but after talking to my mentor, we decided that it was best if I would be able to understand the different types of power generation and the different types of applicables and how they apply to the different fields of businesses, distribution, and anything like that. So the first type of power distribution is called prime power. Prime power is going to be basically any generator that you go rent from Home Depot that's anywhere from this big to a big trailer that you're going to see like this on maybe a large construction job site or anything like that. And what prime power is prime power supplies readily available power depending on the different, at a varying level of load. And what a load is the load is the amount of power that can be taken from the generator as well as applied to the job site. So the load would be how many drills you have plugged into it, how many air compressors you have plugged into it, and just that kind of thing. The second kind of power is continuous power. Continuous power is going to be something that you're going to find in a remote location, probably in a mining operation offshore, maybe on an oil rig, or anything out in the middle of nowhere where there's not going to be any accessibility to a power grid. And a continuous power generator basically never stops unless there's a failure. So it's constantly providing power for a consistent amount of load, which means it's going to be providing power for a set number of buildings, lights, electrical outlets, fridges, microwaves, basically everything that's going to need to happen in order to keep the job site going continuously. And the third kind of power is a standby or a backup power. And obviously it is exactly how it sounds. It is for standby and backup. So this is going to be in any kind of hospital, any kind of business that wants to keep their power running 24/7. But it's also going to be found very closely with continuous power, because if there is a continuous power and for some reason it is to fail, they need to be able to keep the power going, and they don't have an electrical grid to tap into. So there's going to be a standby generator, whether it be big or small, that's going to be able to take over that continuous power's load until they can diagnose and troubleshoot the problem and figure it out. When I was going through my original work, I was able to finally see the different types of applications and how many different concepts and ideas came into creating a generator and an engine and being able to package it correctly. So the packaging for an engine, instead of not putting it in a box, is going to be like this generator is packaged on a trailer with a casing around it that's going to keep it out of the elements. It's going to have an electrical system here. There's air vents all on the side for an air intake. There's going to be this bottom half of the trailer is going to be the fuel tank. That's where the fuel system is going to be located. It's going to be able to pull all the power into the engine and keep it running. And excuse me. So being able to understand the different types of systems that that were involved in going into a generator was very beneficial to me, because before going into this, I never thought about, okay, this engine's going to a dusty place out in Nevada or Arkansas or Texas, out in West Texas, where there's going to be a bunch of dirt and dust, and there's going to need to be extra air filters. There's going to need to be a special type of packaging. There's going to need to be a special type of exhaust if it's going to go up north. Where it's going to be somewhere that's going to snow a lot, there needs to be an exhaust that's going to be able to open up without having it covered by snow. So it's going to have to be flipped around. So being able to understand how many different considerations were going into it will really help me understand how diverse an engineer's job can become. It's not just designing, okay, is this engine going to work because it has this many cylinders, or is it going to work because it has this much power? But it was more about the design process and being able to ensure the customer gets what they want, and then making sure it's a safe product. So when I was researching continuous power, like I said, they're going to be used mostly in remote locations. I learned that there's a lot of special attachments that have to go onto them, whether it's going to be more air filters or a bigger radiator because it can't get a certain temperature. Because a lot of the times these are going to be on offshore drilling rigs out in the ocean, and when you're drilling for gas, natural gas, there's going to be excess gas coming out. There's going to be a lot of heat, and there's going to be a lot of flammable gases in the air, whether it be gas coming out of a tube, leak. And a lot of these customers, when I was talking to my mentor and other people at the company, said that when they get a hazardous area power generator, they have to work with the shop floor and making sure that it gets packaged a certain way where they a lot of times they'll have to wrap like a heat blanket around the engine in order to keep it from radiating too much heat at one time, so that it doesn't ignite something in the air. They have to take special care in the exhaust system, making sure the exhaust is is taken care of. And then they have to add more radiators. They have to add better air circulation. They have to add special tubing to make sure that there's a lot more coolant. And then another thing that stood out to me that I had never thought about before is the fact that there's different types of starters. So we all know the basic starter in your car engine. It's usually an electrical starter or mechanical starter, which is an electrical spark. Ignites the fuel in your pistons, gets them going. But I didn't know there was a second type of starter called a hydraulic starter, and it functions by pushing a bunch of air pressure into a cylinder that gets a turbine going that gets your engines kick-started. And a lot of times those will be used in continuous power situations because there's such a amount of hazardous that there cannot be any spark of any kind, and that was and that you have to put a hydraulic starter on it. And that really stood out to me, knowing that I had never known that before, and I would never have thought about it. And I told that to my mentor, and she's like, that's exactly why you go to school. That's exactly why you have to learn all the different types of applications there are, and being able to understand how how diverse the field really is. So when I was researching standby power, I learned that you probably think there are a lot more in hospitals and stuff, but in the actual ratio, there's a lot more standby backup power generators in commercial businesses than there are in hospitals. Usually, for every hospital, there's about 3 businesses that have standby backup generators on their building, on their premises, whether it's on the roof or in the basement or in a control room. And I didn't know why. I didn't know why a business would want to be able to run power when there's power outage, because usually that means that no one's at work anyways because it's a snow day or a bad weather day or otherwise. So what I learned is that when a power outage goes out and there's a lot, and the company has a lot of data on their computers, it's very easy for it to get hacked into because there's no security system. I never would have known that if I hadn't researched it. So being able to, I actually did a lot more research outside the mechanical engineering area into businesses and found actual websites and companies that sold specific kind of generators that weren't industrial of that size, but actually just provided generators that were going to keep the security system running for their computers and their hardware and their hard drives, and being able to make sure that their company doesn't get hacked into. Because when you think about it, if a power outage were to happen to, let's say, Apple, without any security system, someone can hack in, someone can steal all their files, and the next thing you know, there's another company coming out with the iPhone 7. So that was really interesting for me to be able to understand the different types of applications of just power, standby backup power, as compared to just thinking it was for hospitals and stuff of that sort. So in conclusion, I'm going to have my quote. A dream doesn't become reality through magic. It takes sweat, determination, and hard work. And that quote was from Colin Powell, who was the former Secretary of Defense for the U.S., and that quote could not be more true to any person in this room or any person in this world. Nothing happens because it just happens. Everything you're going to have to do, whether you want to be a professional athlete, you want to become a teacher, whether you want to experience the world, you want to travel to Europe one day, you're going to have to put some work into it. You're going to have to make the money to do it. You're going to have to You're going to have to build up the athletic ability, etc. And in this class, that is all the more true because you have to be able to put in the effort, put in the work, and be able to be committed to your final product and being able to be committed to your year-long goal. Thank you.